Finding equations of tangents with Tutor. Here's the beginner question, one of the easier questions that you're likely to find on this topic. A tangent is a straight line that touches a curve at exactly one point without crossing it, shown here with the point 3, 9. When you stumble across these questions in an exam, they tend to use a circle in the form of x squared plus y squared equals r squared to represent the curve part. Since the tangent is a straight line, we can find the equation by using y equals mx plus c, where m is the gradient, a measure of how steep the line is, and c is the y-intercept, which shows us where the line crosses the y-axis. Firstly, I'll need to start by finding my gradient, and I can actually do this using perpendicular lines. Since the radius of a circle is perpendicular to the tangent at the point of contact, this links to a circle theorem, where the radius meets a tangent at a 90-degree angle, therefore meaning the radius and the tangent are perpendicular. I can use the coordinate provided to find the gradient of the radius. By looking at my rise over run from the origin, we've gone positive 3 in the x direction and positive 9 in the y direction. Therefore the gradient of my radius is equal to the rise over run, 9 over 3, which is 3. Since I know the radius and the tangent are perpendicular, I can use the gradient of the radius and my negative reciprocal to find the gradient of the tangent. So flip the fraction upside down to become 1 over 3 and change the sign from positive to negative. Therefore the equation of the tangent must be y equals negative a third of x plus c. Now I can substitute the x and y values of a coordinate that I know lie on the line to eliminate x and y and find the y-intercept labelled as c, when x is 3, y is 9. So 9 equals negative a third of 3 plus c. Simplifying gives me 9 equals negative a third times 3 is negative 1 plus c, and adding 1 to both sides to isolate c, which is equal to 10. Lastly, I can rewrite the equation y equals negative a third of x and replace the c part for 10, which I've just worked out to be my y-intercept. So the final answer is y equals negative a third of x plus 10. On to the intermediate question with an increase in difficulty. We have another circle in the form of x squared plus y squared equals 25, and this time we have multiple tangents which touch the circle at 2 points of A and B. The point A has coordinates 0, 5, and the point B has coordinates 3, negative 4. The tangents meet at the point P, and we need to work out what the coordinates of this point are. To do this, we'll first need to find the equations of both of the tangents. Once we have the two equations, we'll be able to solve them simultaneously to find this point of intersection and the solution between the two. We can do this quite easily for the first tangent, which I'm going to label as line 1. The reason for that is it's just a horizontal line which always has the same y coordinate of 5. So therefore line 1, the equation is just y equals 5. The second tangent, which I'm going to label as line 2, is a little bit more difficult. I can use y equals mx plus c to help me do this. So I'll first need to start by finding the gradient of the tangent. This can be done by first finding the gradient of the radius, which is perpendicular to the tangent. Considering the rise and the run, from the origin, I'm positive 3 in the x direction and negative 4 in the y direction. Therefore the gradient of the radius is rise over run, negative 4 over 3. Since it's perpendicular, I can use the negative reciprocal to find the gradient of the tangent, flip the fraction, 3 over 4, and change the sign from a negative to a positive. I can now substitute into y equals mx plus c and begin to find my y-intercept by substituting a coordinate which I know lies on the line. That coordinate would be b, 3, negative 4. Take the x and corresponding y value and substitute. Y, which is negative 4, is equal to 3 over 4 lots of 3 plus c. Simplifying, negative 4 is equal to 9 over 4 plus c. Without a calculator, I'll find it easier to add and subtract fractions if the denominators are written with the same number. Timesing negative 4 by 4 to give me negative 16 over a common denominator of 4 is equal to 9 over 4 plus c. Subtract 9 over 4 from both sides, and c would be equal to negative 25 over 4. Therefore y is equal to 3 over 4x minus 25 over 4. Now I have the equations of the two tangents, I can solve these simultaneously to find out where they intersect. Since y is equal to 5, I can replace y in my other equation with 5, and this is equal to 3 over 4x minus 25 over 4. Multiply through by 4 to eliminate the denominators. 20 will equal 3x minus 25. Add 25 to both sides, and we'll get 3x is equal to 45, and then divide through by 3 to give us x is equal to 15. Once you know the x part of the coordinate is 15, you can substitute this back into the original equation to work out what the corresponding y value will be. So y is equal to 3/4 of 15 minus 25 over 4. Y is equal to 45 over 4 minus 25 over 4, which means y is equal to 20 over 4, and 20 divided by 4 gives us a value of 5. So P's coordinate has an x value of 15 and a y value of 5. Therefore, the coordinate of P would be 15, 5. On to the advanced question, one of the trickier questions that you're likely to find on this topic. The graph shows the circle of x squared plus y squared equals 34. For part A, we need to find the value of A, and A forms the y part of the coordinate P. I can do this by substituting in the x part of the coordinate into the provided equation of the circle, and this will give me the corresponding value for y. So if the x part of a coordinate that lies on the circle is -3, then -3 squared plus y squared will be equal to 34. That's the same as 9 plus y squared is 34. And if I subtract 9 from both sides, I'll get 25 before square rooting to find plus or minus 5. Use the diagram to contextualize the problem. If my y coordinate was -5, then that should lie below the x-axis. So even though it could have been plus or -5, in the context of this question, the coordinate is above the x-axis, so it must be +5. For part B, I need to find the equation of the tangent to the circle at the point P. Now I know the coordinate of P is actually -3, 5. This will be helpful a little bit later on. Start by finding the gradient of the radius, using the rise and the run. The run is -3 and the rise is +5. Therefore the gradient of the radius is the rise 5 over the run -3, which is just -5 over 3. Use the negative reciprocal to find the gradient of the tangent, since they're perpendicular. Flip the fraction upside down, 3 over 5, and change the sign from a negative to a positive. Now substitute into the equation of a straight line y equals mx plus c, where m is the gradient just found, 3 over 5. I can substitute the x and y values from a coordinate that lie on the tangent. When x is -3, y is 5. 5 is equal to 3 over 5 lots of -3 plus c. Simplify, 5 would be equal to -9 over 5 plus c. And writing with common denominators, 5 can be written as 25 over 5. And then adding 9 over 5 to both sides to find c. c is equal to 34 over 5. Rewrite the equation of the tangent with my newfound value for the y-intercept. Y is equal to 3 over 5x plus 34 over 5. And I can use this to find the area of triangle OAB, which has been highlighted. B is the y-intercept, which would be 0, 34 over 5. The y-intercept is when x is equal to 0. I can find the x-intercept, which is where A lies, by making y equal to 0. So if 0 equals 3 over 5x plus 34 over 5, I can multiply through by 5 to eliminate the denominators and make this easier to solve. 0 would be equal to 3x plus 34. Subtracting 34 from both sides and dividing through by 3 gives me x, which is -34 over 3. Lastly, the area of triangle OAB can be found by doing half the base times the height. The base goes from 0 to -34 over 3, which in terms of length would just be a value of 34 over 3, and the height goes from the origin to the y-intercept, which is 34 over 5. This gives me a final answer for the area of 578 over 15. Here's a question that I've completed earlier. It appears as though I've made some mistakes. Pause the video and let's see if you can spot what they are before writing some corrections in the comments below.
Thanks for watching. If you found that video useful, don't forget to hit the like button and leave a comment. If you're struggling with topics or finding maths difficult, subscribe and turn on notifications to receive regular updates about new video tutorials and other useful content. You can visit and follow all of my socials by clicking the links in the description below.